Today's lesson is on section 2.4, factoring and solving polynomial equations. I first want to show you some general types of quadratic expressions: the general trinomial, perfect square trinomial, difference of two squares, and common monomial factor. And I want to refresh your memory of some ways that we can factor these things easily. So first off, the general trinomial allows us to split a quadratic trinomial into two quantities that are multiplied together. So we're just factoring like we did back in section 1.3, 1.4, and really dividing that out into two components. The perfect square trinomial allows us to do just what it says. We're factoring as though we typically would, however our result is going to be a perfect square, quantity squared. The difference of two squares tells us that if I have the first term that's squared in my polynomial and a second term that's squared, I can split that into two quantities of the square root. So 9x squared is a perfect square from 3x. So when I divide that out, I get those two quantities. Lastly, a common monomial factor just means that I can pull the same factor out of each term in my equation. A key concept in factoring polynomials is that a polynomial is factored completely when it's written as a product of unfactored polynomials or unfactorable polynomials. So I know that I'm completely factored when all the pieces of my polynomial can no longer be factored any further. Moving on to example number 1. It says find a common monomial factor. So in my first example, I can factor out an x. I can take an x out of each term in that equation. And then I can factor the remainder of that equation into two components. Remember, we do this by pulling the factors of the constant, so 15, and then of combining it with different values to see how we can get our components to factor back together into equaling that original expression. Part B, again, I'm going to factor out a common monomial, which just means I'm going to factor out the 2y cubed. And what I'm left with is y squared minus 9. And that, of course, is a difference of two squares. So I can pull out a y plus 3 and a y minus 3 to factor that down to its basic level. Example C also lets me to factor out a common monomial, which is 4z squared. And then, of course, there is a perfect square within that z squared minus 4z plus 4, which is z minus 2 squared. Example 2 has a key concept. It says the sum of two cubes, so a cubed plus b cubed, is the same as a plus b times a squared minus ab plus b squared. And the difference of two cubes, a cubed minus b cubed, is the same as a minus b times a squared plus ab plus b squared. Those are just simple factorable rules that we can look at, and if we can think about those formulas, we'll be able to factor much more simply. So example A says x cubed plus 64. We know for a fact that that's x cubed plus 4 cubed. 4 cubed is the same as 64. So I can use that sum of two cubes pattern to rewrite that as x plus 4 times x squared minus 4x plus 16. Of course, in example B, first I can pull out a common monomial, which is 2z squared, which leaves me with 2z cubed minus 5 cubed, which is a difference of two cubes. And then I can use the difference of two cubes pattern to say 2z squared times 2z minus 5 times 4z squared plus 10z plus 25. The more we continue to factor polynomials, the more you'll see that these special factoring patterns are really useful as we move forward. Again, another factoring pattern is called factoring by grouping, and what that tells us is that RA plus RB plus SA plus SB is the same as R times the quantity A plus B plus S times the quantity A plus B, which is also the same as R plus S times A plus B. And we know that from section 2.3, when we were finding the product of polynomials, when we were multiplying. Now we're actually undoing that, we're factoring. Example 3 has us practicing that factoring by grouping pattern. And so in part A, we have x cubed minus 3x squared minus 16x plus 48. We can see that we can pull out the x squared and the 16 so that we have x squared times x minus 3 minus 16 times x minus 3. Use the distributive property and the difference of two squares pattern to get us to x plus 4 times x minus 4 times x minus 3. Example 4 asks us to factor polynomials in quadratic form. We'll go over this in our next class along with examples 5 and 6 so that we can really work through this together. I know seeing several of these equations can be challenging at once, so give yourselves a little break, and I'll see you next class.